take another minute or so. All right. Let's kind of wrap it up, and let's see here. George, what do you think of when you hear the word inheritance?
I was kind of equating it to the things that I know about inheritance.
Yeah, that's what we're asking. Like we're talking like in general terms, right?
Yeah. So I was thinking you get traits that are passed down that both parents might hold.
Yeah.
There are things that that don't necessarily, you didn't generate, but that you are receiving the benefit from.
Cool, great. Joshua, where do you think add a reader and start equal come from?
I'm assuming those are that is code that is inherited into kind of where we're operating within any class. So I guess there's like a super class that passes those that code into.
Yeah, like it's got to come from somewhere, right? Like it doesn't just magically kind of poof itself into existence, right? And so today what we're going to do is that we're going to talk about like inheritance and how it's one of the big things about OOP, right? You've heard us refer to the 4 pillars of OOP, and inheritance is one of them. We're going to talk about what it is, we're going to define it, and we're going to like talk about why we use it and show you some examples of when we use it. We're going to show you how like to do some method overriding, and we're going to show you what's called the single inheritance principle. LE, yes, LE. We had to make a split-second decision whether it's LE or AL, and it's LE. And so, like, I don't want you to get kind of intimidated by the idea of single inheritance principle. It sounds fancy, but it's not. It's a straightforward concept. We're going to talk about that in a little bit. So, the idea of inheritance, in like super big terms, is that inheritance is a technique that we can use to use code that's defined in one class in more than one, in multiple classes. And the idea is that one of the big benefits is that we get a reduction. Oops. There is a reduction in duplication from defining methods on a parent class that can be used across many child classes. And if you're looking at the lesson plan, we reference Sandy Metz's practical object-oriented programming in Ruby. And she has this a really good, a highly technical definition of inheritance. And it is inheritance at its core, a mechanism for automatic message delegation. It defines a forwarding path for not understood messages. And you're like, what does that mean? Like messages, like we've never talked about messages in Ruby. And I think that, so what we're going to do is that we're going to dig into a little bit into more about what inheritance is. And in doing that, we'll kind of understand what this whole idea of messages is. And I think the big picture is that you've been using inheritance already, right? So whenever you do this, that's a class thing test. When we do this here, this is inheritance. This bit here that less than mini test colon test says that, hey, what we're going to do is that we're going to inherit the characteristics and behavior from the test class of the mini test module. I should write that down. Inherit the characteristics and behavior from the test class of the mini test module. And so, like, you went through modules a bit yesterday, right? Yes? Time is fuzzy for everyone. And so, like, this is not the same thing as mixing in, which you checked out yesterday. This is a different use of modules called namespace, and we're not going to go into that too much. We're not going to go into that right now. But essentially what we're saying here is like, hey, we are inheriting from this other object. So this is so you've been inheriting previously, and that's great. And we got some rules when it comes to inheriting, right? One, the objects modeled using inheritance must demonstrate a generalization specialization relationship. What we do here is that we try to use inheritance as a technique that we can kind of define code in a way that lets us kind of like separate things in our mind. I think a good example of this is like, let's say we need a program to track all the dogs because this is our life and we're living in this perfect world where we got to track all the dogs and learn about all the dogs, right? We would have a dog class, and inheriting from this dog class, you could have like a husky class that inherits from dog class. And this is kind of what we mean by that generalization specialization. Like the object you're inheriting from is this general object, and and we have a specialized, like a husky is a subset of dogs in general, right? So it's like we want to go in that direction rather than, it doesn't really make sense to have a dog object, a dog class that inherits from like a husky class, right? That doesn't really work that way. It goes the other way around. Other examples, a truck class would potentially inherit from a vehicle class and not the other way around. Yeah. Do you want more examples? We good? Cool. Cool, cool. Awesome. So when we inherit from a class, we receive access to all of the methods and all of the instance variables. We are going to see that in action in a little bit. The inheriting class, did I spell that out? Yeah, is called the child or the subclass. So in the examples I just used, the husky is the child or the subclass. The truck is the child or the subclass. The class inherited from is called the parent or superclass. So the dog class is the parent or superclass. The vehicle class is the parent or superclass. A class can only inherit from one parent. So a husky can only inherit from a dog class. It can't inherit from a dog class and a cat class, right? It is just one. And this is what we were referring to when I talked about single inheritance principle. Single inheritance principle is this idea that an object can only inherit from one parent. Cool. Class, nope, sorry. Also, these notes, I'll post these in your channel when I'm done. Connor?
So what if the inherited class or the parent is also being inherited or inheriting another class, chaining.
I'm just going to talk about that right now.
Oh, got it.
Yep.
Sorry.
So yes, you can do that, and the idea is that you can have this chain, right? And the chain of parents, and parents, is called ancestors. Anything above, right? I went a little nuts with the parents, but like the idea is that anything above are referred to as ancestors. Will, you got your hand up there?
Yeah. Why do they have the principle of single parent inheritance?
Can we put a pin in that? I think that will become clear once we go into some examples. The idea, the big picture is like, the big picture is that we talked about, I mentioned Sandy Metz's quote about inheritance at its core is a mechanism for automatic message delegation. This idea is that when we can't find a method in a object, it's got to go looking for it somewhere. And so how it works is that we'll go up this chain of ancestors looking for it. But if we have a thing that goes up to a chain of, like, it has two ancestors, like how does it know which one to go to? Does it check both? Does it check one or the other? What order? Like we have a lot of complication here. And so when we have this single inheritance chain, it's like, it just goes the one way. It's very predictable. It's expected. It's reproducible. Honestly, I'm sure there's probably a lot more, a more technical reason why.
Makes a lot of sense.
Yeah, but like I think that like from a practical standpoint, what if something doesn't work like the way you expect it to, right? And you're trying to figure out like, well, which way is it going? When you have potentially inheriting from like 5 objects, and then those 5 objects, every single one of those 5 objects inherits from 5 other objects. Now we've got this tree, like potentially like this, essentially the whole giant family tree going upwards, and you got to pin down a thing. That's difficult. Cool, Garrett.
Yeah. So, like, just like listening to this, and then also like connecting it to some of what we talked about yesterday. So it sounds like, we have classes, and then we have like instances of those classes, and we also have modules, and now we also have these inheritance. And so in my head, I'm trying to like, so I get it, like maybe you don't want to make something an instance variable because it has a lot of similarities, but it's different enough where that you want a new class to maybe have some unique methods, but also inherit some of the old methods. Yeah. So when I do that, why not create when do I create a module versus when do I use inheritance?
So we're going to go into this a little more in depth, but like the short answer is that in my opinion, like a inheritance I would use when there's like kind of a logical definition, a logical separation between things. Like I want to model the fact that, I've got some stuff that's shared between dogs, but I also have like individual breeds of dogs. It's like this, I see inheritance as a tool for where I want to organize things in a logical manner in my head, and this makes more sense to do it that way. Like there are definitely going to be circumstances where modules are going to be the answer. There are going to be circumstances where inheritance is going to be the answer. There's going to be instances where you're like, I don't know which one to use, and like that's fine. We are giving you like a variety of tools in order for you to like try to determine which one makes the most sense for right now.
So maybe it's like the two classes you're using, maybe if there's like some sort of slightly more tightly like logical connection.
That's a great way to put it. Like I think that when it makes a logical sense, and I don't mean logical in the way like, oh, this makes sense. It's like a logical in terms of like, like a Husky is a kind of a dog, right? I think that the key word that we talked about here is this first rule. The objects modeled using inheritance must demonstrate a generalization-specialization relationship. When we have like a dog is like a general term, a Husky is like a specialized term. One thing we could do is like when we think about websites, you have a user, but some users are also admins, right? Like that is a potential way you could break that up as well. Cool. Joshua.
So in the example with the Minitest test, you said Minitest is a module. So the test, so the test class of the Minitest module. So I guess I'm a little confused at how those are structured. So like there's this class that is a part of a module.
Yeah, we're not going to like go really super in depth right now. The idea is that that's a technique called namespacing. The idea is that there are methods in Minitest that like there are a finite number of words in the English language. And the idea is that what happens if we have two modules that use the same word as a method, right? Which one does it pick from? Namespacing says like, hey, it belongs to here. And that's how we kind of get around. That's the purpose of like how that is structured particular. So if you'd like to get into that, I would look up namespacing in Ruby. It'll give you more detail about what's happening there. But essentially the practical usage is like, we just don't want like an overlap of method names.
Okay, thank you.
Yeah. All right, where was I? Scrolling. Cool. Next is that any number of classes can inherit from a single superclass. So like this example we're talking about with the dogs, like you have the dog general class, and then you've got the like a husky subclass, child class, why can't I think of any dog breeds off the top of my head? Oh my gosh. Because I don't want to say like any like lesser dog breeds. I'm not gonna, I don't trust people that own small dogs personally. But like you have husky, golden retrievers, Swiss mountain dogs, like these are all like, I don't even know how many kinds of breeds of dogs are there. The idea is that the number of things that can inherit from a single superclass is infinite, essentially infinite. Multiple. Right. And so like someone asked, like, when do I use modules? When do I use inheritance? Inheritance, like the whole big picture of why we're talking about modules inheritance is that we want you to write less code, right? Less code is more gooder. And these are two techniques in that we can kind of cut down on this replication of code. And the main point of when we would use inheritance is that it is convention to use inheritance when there is a relationship between two things. And I love this is a husky is a dog, a truck is a vehicle, a whale is a mammal, water is a drink. Yes, water's a drink. Cool. All right. Let's pause here. Is there any questions at this point about what we've talked so far? It's been a lot of like kind of like theoretical things, and after we answer some questions, we're going to kind of look into like the nuts and bolts and nitty gritty of how it works, and give you an opportunity to do so as well. Will.
Yeah, maybe we'll get into this, but so when would you, Meg yesterday seemed to distinguish the importance of modules versus inheritance, and what's sort of the thought process is when you start thinking, oh, I should have used a module versus I should think of inheritance?
Yeah, I think that like this whole is a thing. Okay. I think that when I think about how I can reduce code duplication, I think to myself, I'm like, well, does this code like just need to be reused somewhere, or am I modeling things that have that is a relationship? Like for example, when we think back to your Battleship project, right? Like all of the messages that I print out on the screen, I would have pulled that out into a module. because that means I can reuse it. But I'm not really modeling anything, right? Like I have these messages or strings that print on the screen. They don't really have that is a relationship with anything at all. They kind of just kind of exist and are used in multiple places. Whereas if I'm creating, dog tracker, no, I've got lots of kinds of dogs and they all are lots of breeds of dogs and they are all a kind of a dog, right? And that's kind of like the distinction I would make. I think that is a generalization specialization model is probably my first kind of thing to think about when I decide if I use inheritance. And we're going to talk a little bit more about this a little later, but the thing is inheritance should not be your first reach. You don't start, it's not a really good idea to start off yes, inheritance right away. And I think that inheritance does come with some overhead. You have to create multiple class files, multiple tests. I think that inheritance is more something that is generally done in kind of a refactoring step. Because let's say if I'm making a dog tracker and hey, I guess it turns out I'm just tracking huskies. Did I need to go through the whole thing by creating a dog superclass? I didn't need to do that. I think that as you write your code in the projects, you will see oh, this is a place where I can refactor use inheritance. It really isn't something that I would be my first reach. Don't start off using inheritance. I think that potentially you'll over engineer something that you'd never use at all. Aiden?
Yeah. In a different answer to Will's question, I think that the way I think about it is that for example, our vehicles thing yesterday with Meg, a truck is a car, a vehicle. So a truck is a car, and that if we had a car class, we would probably inherit from that for the truck for the engine and the wheels and whatnot. But for the module, the air conditionable module that we had yesterday, the truck is air conditionable, but it does not inherit from the air conditionable class because it's a module. Does that make any more sense?
Yeah, I think it's good to have some examples like that. Thanks, Aiden.
Cool. It is 9:26. Let us take a Pomodoro break. We'll be back at 9:31. 9:31. Recording. Excellent. So we're going to give you some, take a look at some code and see how this all fits together. So what we're going to do is that we're going to show look at superclasses and child classes. We're going to talk about the lookup chain, and we're going to look at some instance methods. All right. So first, we've got this employee object, and do that. Cool. We have an employee class, and essentially has one method in it called base salary and bonus. And I'm just going to make a CEO object. And what we're going to do is that we are going to create a CEO class that inherits from employee. Well, the first thing we have to do is have it require the employee file, right? Because how can we inherit from something if we don't know where it is? Cool. And it's going to be the less than sign. Typing is hard today. slow down. That doesn't help. Right, and then what I'm going to do is I'm going to make this runner file that's going to acquire CEO, and Allie is going to be our new CEO. And their base salary is going to be 15 ducats, and the bonus is going to be 20 ducats. And then we're going to do a puts Allie dot total compensation. Cool. And I'm going to run this runner file. And we see here that it prints out 35. And kind of like the idea here is that we didn't define total compensation in our CEO object, right? We define it over here employee. And because the CEO object still responded to this method, it's like total compensation still worked because it inherited from employee. In this example, CEO is a subclass or child, and employee is a superclass or parent. And the idea here is like, this is when we talked about Sandy Metz's definition earlier. And in her definitions, he talks a lot about sending messages. And the idea here is like, when we are calling methods, we're essentially sending messages to each object saying, hey, I want you to run this method. And so what happens here is that when I do this, Allie.total compensation, when I'm saying like, hey, Allie, I would like you to run the total compensation method. And because if I typed, if I do this, let me do this, puts Allie.class, and I run it again, I see that the class is CEO, it prints out CEO. It's going to be looking like, hey, I'm in the CEO object, the CEO class definition. I want this method called total compensation. And the CEO object is like, well, I don't have a total compensation method. So where do I go next? And what I'm going to do is that I'm going to go to my parent, and I'm going to send the message like, hey, employee object, employee class, do you have a total compensation method? And it's like, yep, I do. We'll do the things and return that out. And this is what we're talking about, like when we talk about the this kind of like this lookup chain of like how things go to find methods that aren't like defined right there. This is kind of like what we were talking about earlier, like why we do, like one of the reasons, like one of the reasons I think single inheritance is great, because it's like, hey, things work in an expected kind of path, right? And I think that because of how we think about inheritance of things getting passed down, like how George said earlier about how traits and genetics gets passed down. I think like we think of inheritance like your rich, the trope of the rich uncle or aunt, passing away and giving you inheritance, things go down. The idea here is that I think in programming, we need to think about things are getting passed upwards, right? Methods on this child object are getting passed up to the parent class. When we try to call this message on employee, it cannot find it, and therefore that message is then passed upwards to the parent class. It is delegated upwards. Joshua?
Oops. I guess two questions. First is, if you were within the employee class file, if you were to name base salary and bonus as instance variables, so if you put the @ there, would it work still?
Like over here?
Yeah.
Yeah, it would. They'd have access to the things.
Oh, okay.
Yep.
And the other is, so in this example, you don't have instance variables within the class employee, but the subclasses can still inherit those?
Yeah, we're gonna see that in a little later on.
Okay, thanks.
Yep. Garrett?
Yeah, so this seems really helpful. I can see how, especially for reducing code, right? Like I could have, I mean, we've brought up this term of a superclass. Like I could essentially have employee have all my methods for different types of employees, then have different classes for each type of employee that essentially don't really need to have that much code. I guess the question I have is, what are the tools that I have to reduce the total code in my superclass? Because I still don't want that class to have, over the 150 lines, for example, or whatever that.
Yeah. I mean, I would say like the standard refactoring techniques. The idea is that like by creating a superclass, you are drawing out your code from a lot of subclasses, right? We're figuring out like, hey, we got a lot of repetitive code in all our subclasses. We can pull that upwards to the superclass. Does that mean that there may be code in your superclass that the child class, like a child class, could potentially never get used? Yeah, potentially that is the thing. And I think that because of how things are structured and how like it's going to be different for every single code base. For example, let's say for a dog, going back to the dog example, it feels reasonable that it has a method called shed because dogs shed, right? But at the same time, there are I want to say small number of dogs don't shed, right? So if we're going by that breed example, like, yeah, like most of them are going to use the shed method, but a couple of them might not, right? But, and at that point, I'm like, yeah, like that still makes sense to have that be stored in the superclass, right? Whereas, like just the random example, and this may not make sense. Like, what if not many dogs howl, right? Do we still want to put that howl in the superclass, and not in the dogs that howl? Like, like this becomes a very kind of like, well, it's gonna vary with each case, and I think that like as you get more like as you are working in a code base, you'll have a better feel for like when do I need, like you're always gonna have these exceptions, these weird edge cases. That's why we have this idea of superclasses and subclasses, right? But like a lot of that's gonna be pretty discretionary. Like it'll make sense to you when you think about it. Like like these are just two examples I came on the top of my head. Like you can probably think of a couple others on your own. And I think the decision is going to be based on what you think is appropriate. Jesse.
Yeah, I have two questions. The first one I think is similar to what Josh asked. So a child class has access to the instance variables of a parent class and vice versa. That works both ways. Is that right?
No, because when we think about it, right, if you just instantiate an employee, right, like how is CEO going to get involved? Is that right? So it doesn't kind of work in that direction. And let's keep going, and I have some other examples that kind of push the edges of what we're trying to do here, and I think that will make things a little more clear, right? So let's.
Okay.
What was your second one? Yeah.
And yeah, the other one had to do actually with modules. Now, so in line with that, having access to instance variables, can a module inherit from a class so that an instance variable can be used from a class in the module? And I'm not sure if that even makes sense, but.
I'm not sure because I've never tried it, but I wouldn't want to structure it that way, because the idea is that like I feel that inheritance here is this kind of is more of a logical tool, in that we are defining a relationship, right? Yes, it helps us reduce code, but I think it's also a tool we use to like kind of wrap our heads around like how we're trying to structure the structured code. Like by using inheritance to define a dog and a breed, we're communicating that like, hey, A dog has many different kinds of sub things, and they're called breeds. Right? It is more than just like a technique to kind of dry up a code. If I was just looking to dry up code without any kind of structure or module, people might kind of like be my first reach. But like this idea of the inheritance is really kind of centered around this generalization, specialization idea. Will?
Yeah, so I think this will be a quick yes/no question just to help my understanding.
Sure.
But if we move the add a reader and the initialize method from CEO into employee, could we call those instance variables and the add a readers from CEO?
Yeah, let's put a pin in that. We'll see like some more examples using instance variables.
Okay,
George?
Yeah, I was just looking back at the notes. Would you say then that like using inheritance is the place that we do bring in state? Because Meg was talking about like modules don't bring in state, but inheritance would be bringing in state? Or potentially?
Inheritance by definition, like by like how are you setting up classes, everything is stateful because we are creating instances of objects.
Okay. Okay.
Modules are not something that I would use to like really use state. Like I use like I personally use modules as kind of like this grab bag of just like shared code. Right. Cool. All right. So got that. All right. So what I'm going to do is I'm going to copy and paste this code into your channel. I'm going to break it up into groups. I'd like you to take about 10 minutes where we will and I want to put this up in your Slack. I'm going to put the instructions in your Slack channel. And what you're going to do is you're going to create a sales manager class that inherits from employee, takes the base salary, estimated annual sales, so obviously initialize. We're going to create a bonus on sales manager, returns 10% of estimated annual sales, and create a new sales manager in your runner file and print their total compensation to the terminal. So where is, oh, there we go. Let's make the breakout rooms. Just make sure we're good. Yeah. There we go. Let's take 10 minutes. All right. Where were we? We just did some sales manager stuff to clear your threads. That was fantastic. So where are we? Let me reorganize my windows. Because like Zoom, you take up so much space, but you're so not useful to me at times. All right. So we're going to talk about this method called super. And what this method super does is that it calls the method from the super class with the same name. So like, let's say we have super inside the CEO's initialize method. It would call the initialize method from within employee. So what we're going to do is that we're going to kind of extend and like add more to this bit of code that we've been working on here. Where's my participants thing? I need to make sure that's up. Wait, so I can see if y'all have questions or not. There we go. There we go. All right. And so what we're going to do is over here in employee. And I think that this will kind of address a lot of the questions people are having about like, well, what instance variables do I have access to where? And like, we're going to take a look at this in depth and not in depth, but you're going to see how this works and see like how we have access to things. So here, we're going to add a def initialize, and it's going to take a name ID. Cool. So the thing is that we, if we're going to pass in a name and ID, we need to update our CEO object to take a name and ID as well. right? So rather than doing like, well, you know, we gotta do the name ID, right? But I think our next kind of step is like, we would probably be like, oh, I know how, wait, let's keep this in order. Find that person. Name equals name. I think that this like would be something that we kind of reach for naturally, right? But like, no, like why do we have to do this when we can just put that in employee? We're saying here that every employee is going to have a name and ID. And let's say if we had another employee like that for that sales manager object you created, right? Like that means that we have to set you know, at name thing there too, and we have to essentially duplicate this for every class. Like, no, we don't have to do that. We can use super. And how that works is it would look like this. So what we're saying here is that like when we create a CEO object, we're taking in these 4 things. We're taking the thing that's unique to CEO, base salary and bonus, we're storing that here in the instance variables. The other 2, we are going to send through the super keyword here to the initialize here. And then we're sending a name and ID, and then name gets stored in that name, ID gets stored in that ID. So so again, what super does is that it looks for the same method name in the parent class and calls that. So because this is in initialize, it's going to look in the parent class, the initialize method. Right? So the call to super calls the employee's initialize class, and then in there is where we are setting the at name and at ID instance variables. So there are 3 forms of the keyword super. Make some notes here. Super. 1, super, like these are just arguments, calls the super class method with arguments 1 and 2 specifically. Right? And that's what we did. We called the superclass method, which is the initialize an employee, and we are sending name and ID specifically. Super calls the superclass method with all of the arguments in the current. So meaning like if I had just called super, like I just done this, it would have passed all of this, all four arguments over to employee, the superclass, which is in this case employee. And lastly, super empty parens calls the superclass method with no arguments. And I know this last one's a little weird because if they're usually for us, if we're not passing the arguments through, then we don't use the parens at all, right? We just call the method. But the idea is that because we're dealing with a superclass and we're calling on a superclass employee, if we wanted to state specifically, I don't want to send anything through, we need to have those parens. Curtis.
So just to clarify, super,
sure.
When you say it calls the method from the superclass, it's calling is it calling like the name and ID methods, or is it calling initialize?
It's calling initialize.
Okay.
So essentially like, it's just like referring, because the thing is I can't really call employee. It's essentially saying like, hey, employee class, I want to create a new employee with these initialize kind of things. But like we're not creating a new instance. It was like, hey, because we're inheriting, I want you to go run this method with the same name that the method I'm currently in.
Okay, so super runs the method that it's called within, but
yeah.
From the superclass?
Yeah. Yeah. So let's say like def, I don't know, do work. Right. And if we ran super here and we have let me get rid of the runner file. So if I were to run the file and I call the do work method, it would print I'm so busy out to the screen. Right? Because super is in here, it's going to look for the do work method in the super class, which is over here, and puts I'm so busy.
Okay.
Right? So yeah, like it's very, like that's a really good point, because like literally where the method lives is determining what gets called from the superclass. Cool.
Gotcha. Thank you.
Yeah, Jake.
So I kind of just had another question off of what you just said. Do you even have to define that method do work in the CEO class to be able to call it?
No, I wouldn't. I just did that to like show like super is going to look for the same method name.
Okay, that's what I figured.
Yeah.
But my original question
sure.
Was on your initialize, is it good practice to use the same like instance variables that you're inheriting? It's like you use name and ID in both of those. Do you have to? Should you? Or does it not matter?
Well, let me go back to the way things were here. 1 second here. Let's say we were here, right? And I think that I want to keep the names the same, so it's very clear that they should be the same. Like you can call us whatever you want. You can call us name. Then you do that, right? But like I think that what that does is that it just increases complexity, and you have to do this translation. Like, well, it's name over here, but it's name over here, and like there's that little kind of like translation you got to do. Personally, I'd probably keep it the same, just so it's like I'm very specific and very clear in my head what I'm doing.
I meant more like not necessarily as far as what you're naming it. Like, do you need name and ID in a class inheriting? In employee or CEO? So in the CEO. So since you have it in employee, is it good practice to also put that same one in?
So if I have it like just like this, right? What's going to happen is that name and ID are just going to be nil because they never get set. Right. We've kind of structured this out this way in that the intention is that every employee is going to have a name and ID, regardless of CEO to mail clerk to, everything in between. Right. And I don't think that there are many kind of like, if there is this is kind of like what we talked about before with the dogs and the shedding and that stuff. Right. The idea is that like, well, I need to really think about like, well, are there going to be any cases that don't have a name or ID? And then I would make that, and then I'd have to make a decision. Like you'd have to make that decision like, oh, how am I going to handle that? Is it enough that we don't put everything in the employee? Is it like just this one-off that we might like, heck, you might not, like in a case where a person, well, maybe name and ID is the bad idea, but like just like for ID, this might be a situation where like you create a separate class called contractor that doesn't have an ID. They may still have a name, right? But like that's a potential, I think that's kind of like what you're talking about.
Okay. Yeah. So it all kind of goes back to the whole relationship and those fit together. Okay.
Mm-hmm. Yeah. And again, like you're going to encounter, nothing is going to be this straightforward, I think, in real life. Right. And like, I think that the challenge of this is like, we're trying to show you some examples so that when you do get to something for this real, like you have like the tools to make the best decision that you can in the moment. And I say in the moment specifically because like decisions you make now they're never going to be like the best decisions all the time, because like, you don't know less about a problem than you do like right now. Right. And so you have to come with this balance of like planning for the future and what things may entail, but like not planning too much because you may never use a thing. Right. So there's this balance you got to figure out and strike.
Cool. Thanks.
Mm-hmm. Will?
Yeah. So in this case, do you have access to the adder reader in employee, like .name?
Yeah.
So you could get his name from there? Okay, I was trying to follow along and it's not working for me, but I might be doing something wrong. So, okay, I just want to know.
Yeah.
Thanks.
Garrett?
So I'm just trying to clarify this real quick. So when I have my definitionalize in CEO and I have a definitionalize in employee. When I call the super within the employee,
yeah,
essentially what I'm doing is just initializing the instance variables from employee. I'm not actually creating a new instance, right? I'm not like creating a new instance. I'm just basically using it to initialize those variables. Okay.
Yep. That is exactly it. Megan?
So since every employee is going to have a name and ID, why do you have it after base salary and bonus and not at the beginning?
Because base salary and bonus came first in this list.
Okay.
You don't have to, but like that's just, I like to put things in order.
Okay.
Now that you ask that, I think I would always put the super at the bottom. Just as kind of personal preference thing. Because I just feel like it just feels like that should do last. I don't know. That's what I don't know. It makes sense in my head. Some of you might agree, some of you might not agree. That's okay. I just think that it should go at the bottom. Because it feels like I need to do all my things in CEO and then I do the superclass stuff, right? That's how it makes sense for me. Like some of you might think like, no, I want to do superclass stuff first. Like, that's fine. But like that's how it makes sense for me. And that, sure. Develop your own opinions. It's okay. Cool. Oh, was there another hand? I thought I saw more.
It was me, but I had the same question as Megan about like the order in which you were doing things.
Okay.
So.
Cool. All right.
So Mike, I do have one more quick question. So if we were to call at name or the name variable in CEO, would we use an @ symbol in that case to do so?
You could do either. I personally would use I would access the instance variable directly.
Oh, you mean we have the option because we had the adder reader.
Yeah. Okay. I think I've said before is that like my personal habit is that I would go for the instance variable directly because that's slightly faster, and like that's just a habit I've built in just from like knowing that. You can use either, it's fine. Like I think it's a pure stylistic thing. Cool. All right. Let us move on to this big picture of overriding. Overriding is fun. Also, it leads us into this dangerous area called monkey patching, which we'll talk about if we have time, but don't do that normally. Overriding. We can override a method from our parent class by redefining it in our child class. And the idea here is why would we do this? Why would we do this? And the big picture is that we override methods from our parent class when we have exceptions, right? And the example in the lesson plan is like, this actually sent me down like a Wikipedia wormhole when I was preparing for this class. In general, a mammal class might have a method called lays eggs that returns false. And you know what? For most mammals, that works. However, the platypus would have a method called lays eggs that returns true, because I did not know a platypus was a mammal. Platypus, I thought that was a bird. Wait, is it? Is platypus? No, it's a mammal. It's a mammal. And so the idea here is that when we define a method that is the same as a method in the parent class, the child method will run and the parent class does not. And we are going to do so. I'm going to show you an example now. I'm going to make an intern file. Require employee, right? And then we're going to do class intern, and intern inherits from employee. and def initialize hourly rate name ID. And we're going to do super name ID, just like we saw before. And so interns, unsurprisingly, do not make the same amount of money as CEOs, right? But also, they do not make the same amount of money, or they don't have the same kind of compensation, financial package that an employee would, right? They are an intern. And so the idea is like, hey, interns, by defining, like we have this, like, okay, interns get paid by the hour, makes sense, right? They're an intern. But like, what if I want to calculate the total compensation? I can't do this for base salary plus bonus, right? Interns don't have a base salary, they get paid by the hour, and they don't have a bonus. So what we do is that we def total compensation hourly rate times 2,000. That seems 2,000 hours? That seems like a lot of hours. How many? It's 2,000 hours. 83 days. Ooh, still seems like a lot. Anyway. And so what happens here is that when we are determining this intern's total compensation, we hit this, we do the class, the instance object name and total compensation. It takes hourly rate, which is defined here, and multiplies that by 2,000. It doesn't hit total compensation employee, right? And the reason why is that, like, let's turn back time, and let's think about our class on scopes. Yeah, I see like 4 of you like bopping your head to the song. Like, don't think I didn't see that. When we define a local variable inside a method, right, and we call it local variable, does it then go look to find sibling methods? It doesn't. Like, it's right there. It finds a thing. Like, I'm not looking. Like, the example I use all the time is like, I lose my keys on average every 3 days. When I find my keys, do I keep looking for my keys? No. Which is, again, this is why I think the term, like, this is the last place you look, like, it's always in the last place you look, because no one keeps looking for something after they found it. Here, when I call a total compensation method on this intern object, it has found the method name. It's going to find that method name. It's going to return the method name. It's not going to go look to its parent to find another method. Like, why would it do that? It's already found the answer, and it's gone and looked, right? And we know the thing, and that's fine. That's it. We're done. We don't look anymore. Like, that's it. And so this is what we call overriding. We are halting the execution of this total compensation method over here in the employee by inserting the method inside our lookup chain. And so when we talk about inheritance, we also talk about the kind of like bigger structure of how Ruby works. When we call a method on an object, if we for here an intern, it's going to look, I'm like, okay, do I have a method called this? No? Well, I'm going to go to my parent. And like, it's going to go to employee. It's going to find the employee. Like, and if it doesn't find it, it's going to go up. It's going to keep going up until it either finds a method in this chain of things or it doesn't find it and it gives us that no method error. Cool. We can also combine super and overriding. So next thing I'm going to do is I'm going to make this def benefits of an employee, and they get sick leave, right? And let's go back to the CEO object, and let's say that the CEO also gets a thing. Def benefits, and we can do super dot push corporate jet, right? And so what we're doing here is that we're trying to keep like making this thing where we get the best of both worlds. When we call the benefits on the CEO, it's going to take the benefits of employee, which everyone gets sick leave, and we're going to add in corporate jet. So the CEO gets both, right? This is a way that we can kind of rely. We can kind of like take like a yes and. My last job, the CEO was actually a really cool guy, and he actually made time to have lunch with every single team as a schedule. And during my team's lunch, we could ask if we could have a ride in his corporate jet, and he said no. Still a little bitter about that one. Like, if I was a CEO, I'm like, hey, you asked, sure, because who's going to ask him for a ride in his corporate jet? Like, just having the gumption to do so, I feel needs some kind of reward. More than just actual lunch. Cool. All right. Any questions at this point? Kind of open it up. Lots of thoughts, lots of things. I want you to be careful as we're kind of starting to wrap this up. I'm going to have some discussion stuff for you to do. Is that like two words of warning? First is that I think that we definitely can suffer from the situation where we think that when you have a hammer, all the world is full of nails, right? There are situations where you're going to see a thing, you're like, oh, I've got a couple things. I'm going to immediately hit this. I'm going to start bringing inheritance right away, right? Like if we are just we have an application for like Denver Dumb Friends League, right? And we want to track dogs and cats. Like we mean like, oh, well, yes, let's make an animal superclass, and we're going to have dog and cat inherit from it. And like, we're going to do this right away. I'm like, here's the thing. Like, if you just have dogs and cats, like, let's just leave it at dogs and cats. Sometimes it is less expensive just to have the dogs and cats than to have animal that inherits from there. Right? Like, don't, like, this, like, one or two, if I have one or two what potentially could be subclasses, I could leave it. Right? I think that your time could be best spent doing other things. The idea here is that, like, in going to that inheritance structure, like up front, you have this danger of painting yourself into a corner of like, you need to have a good sense of what your structure is going to look like. Like, are you going to have, all right, this is a kind of contriving example. Like, what if the Denver Dumb Friends League just starts having rocks you can adopt and you have a pet rock? Like, now you got to have like I don't know, what would be a superclass for rock be? Like matter superclass, and matter, then animal inherits from matter, and then like, no, like that, like what have we done? Why would we have a matter superclass, right? That now we're like locked into the structure, and we're like, I don't understand. Like anyone that comes into like a project, I think like why do you like if I were to come into software that tracked animals and things for adoption at a shelter, and I saw a matter superclass, I'd be like, what happened here? What did you do? So like we want to like hold off on that as long as we can until we have a really good idea of what our structure looks like. And so like the idea is that it's easier to make like things that are it's easier for us to abstract out and pull things out from multiple classes to a superclass than the other way around. Like it's easier to kind of like, it's easier to pull the functionality out into a superclass and rather than like other than breaking apart a superclass into separate objects. Like that's going to be so much easier to do. So we can kind of avoid that. I think that it's also important to know that a parent class should not use methods that are not defined within the parent class. For example, we have our employee class. An employee class relies on this base salary and bonus. So later, if you make like a manager class, that manager class needs to have a base salary and bonus, and that has to be defined in the subclass because the parent class uses it. So you need to make sure, like, you need to understand that anything that happens in the superclass, you need to think about and have to have in the subclass. So like, inheritance is a tool that, for lack of a better term, should not be used lightly. It takes a lot of kind of like planning to make sure it all kind of fits in the right way. Will?
Yeah, sorry, I'm still just looking at this, the benefits method you have there.
Uh-huh.
And it looks like the one in employee is, I think, what we call like a query method, where the one in CEO is a command method. Is that like a violation to have?
No, like this is not like kind of query. Like this is benefits just holds an item. This here is just like, hey, I'm going to take that, add this thing to it, return it. Like this is not something I would call like a command query situation.
Okay, because I guess it looks to me like a CEO, you're telling it you want to change the variable.
The thing is, I'm not changing it. I'm not changing what the benefits are for every single employee. I'm saying that my CEO gets this and.
Okay.
Cheryl?
Yeah, just based on kind of what you just mentioned about, total compensation, base salary and bonus, like the intern doesn't have that. Mm-hmm. So is that just would you still want, I guess you still include them because they're an employee, but it's just one of those special cases? Yeah. So like this is why we overrode it, because this is a special case. You override when you have to take care of like a special case. In general, the idea is that every employee is going to have base salary bonus. And I would say in this kind of like constrained example, if I had a significant amount of interns, I would consider maybe not having total compensation employee. Like again, this is kind of a bit of that of like a contrived example to kind of demonstrate these techniques and how they fit together. If I was building this out, and let's just say like a standard company where you have a very few number of interns, I would probably keep it this way. Because like that intern is probably going to be the one kind of one sort of employee that doesn't have the hourly, the base salary plus bonus, where if everyone else does, like if every single other object, I think that if I have to make more than 2 or 3, if I find myself having to override the total compensation method 2 or 3 times, that's when I'd start to think about what I want to do, if it's worth changing or if I just keep going. But past that, I'm like, yeah, whatever, it's fine. Okay, thanks.
Cool. Other questions? Robert?
So could you set it up under total compensation? Could you use an if statement so that if the class is, say, an intern or a contractor, then it returns one thing? And
you could. You certainly could. But don't really want to do that, because you can see like how that it can get, real quick, right? And the idea is that like that code doesn't really belong to an employee. It really should belong in the specific definition of what we're trying to do, right? But like, yeah, that would 100% work. But for other reasons, I wouldn't do that. Joshua?
Hypothetically, if you included a module here that had a total compensation method within it, would that override the superclass method, or where's the lookup cheat with that, I guess?
I don't know. To be fair, I don't know.
Okay.
Instinct says it would.
Okay.
Yeah, I'm yeah. So like the reason why, like I'm not sure, because I've never done that. Because like I think that when you start doing things like that, you like that's we're kind of like borrowing trouble and we're adding complexity in, where we kind of don't want to do that. Like when I'm writing software, I'm very intentional about dividing things up logically, and also naming things in the right way. Like I personally do not like overriding methods. because I feel that it violates what's called the principle of least surprise. In that if like I expect something to work a certain way, you know, it should work that certain way. I should not make it work in a different way. So like that's kind of I think that as you get a feel for how like all these bits fit together, you will naturally gravitate towards techniques that don't that don't push at the edges of what's possible, right? I think that like Ruby certainly has a lot of places where there are edges that you can push against, and it does weird stuff. But I think it's a good idea to avoid those places. Like Horace, a former instructor, used to describe that like these edges, past these edges, like on those old timey maps, like here be dragons, right? Let's avoid that. Let's not like. I think there's a time to find out what happens because it's interesting and fun. But like when writing code, like, hey, let's stay in nice, safe, green field of good things.
Great, thank you.
Yep. Cool. Let's take a 6-minute break. Let's be back at 10:43, and we'll have some discussion questions you'll talk about amongst yourselves.
Thank you for